Hello students, we are solving the IB Math AA HL past papers and currently we are solving the IB Math AA HL May 2022 paper 1 time zone 1 past paper. Today we will be solving the question number 11 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlist in my channel NS Online Math Tutoring Classes. So, without any further delay, let us start answering question number 11. It contains maximum mark of 15. And it says, consider the three planes pi 1. The equation of pi 1 is 2x minus y plus z equal to 4. Pi 2 is x minus 2y plus 3z equal to 5. And pi 3 is minus 9x plus 3y minus 2z equal to 32. And there are more subparts to this question. The first subpart is show that the three planes do not intersect. Okay. So for that, you may use the matrix method. So I can write the matrix as 2. I'm taking the first equation. First equation will be forming the first row of the matrix. It will be 2 and minus 1, 1. Is an augmented matrix. So this is 4. The next row is for pi 2. It is 1 minus 2 plus 3 and 5. Finally, pi 3. It is minus 9. I'm taking the coefficients. 3 and minus 2. And this side we are having 32. Okay. And actually this I want to convert it to the row echelon form. So first of all, I will be trying to convert these two to zeros. Okay. So for that, let me start with this because this is 1. So let me first of all start with the row 3. And I am doing the operation as 9 R2 plus R3 gives us the present R3. Okay. So the first row stays as it is. And the second row also stays as it is. The third row, 9R2, 9 times 1 is 9 plus R3, that is minus 9. 9 minus 9 is 0. Okay, coming to the second element, 9R2, so 9 times negative 2 is negative 18 plus 3. Negative 18 plus 3 is negative 15. Finally, this one, 9R2, 9 times 3 is 27. 27 minus 2 is 25. And I am having another one remaining. So 9 times 5 is 45. 45 plus 32, 45 plus 30 is 75 plus 2 is 77. Okay, fine. Now let us make this one equal to 0. Okay, so for that I can write over here, I'm from this point I am coming to this place. Okay, and then I want to make this number or this place equal to 0. So what can I do? I can write 2R2 2R2 means 2 times 1 will be 2 minus R1 gives us the present R2. Okay. So it will be the first row will be staying as it is. 2 minus 1, 1 and 4. And this one is 2 times R2, that is 2 times 1 is 2, minus 2 is 0. Okay. And this is minus 2 times 2 is minus 4. And minus of minus 1 is plus 1. So minus 4 plus 1 is minus 3. This one, 2 times 3 is, because it is 2R2, so 2 times 3 is 6. 6 minus 1 is 5. Finally, this 2R2, so 5 times 2 is 10. 10 minus 4 is 6. And the R3 stays the same. So it is this. Okay. Now, next, I want to have this as 0 because that only then when I convert this to an row echelon form. So for this, I need this to be 0 and this for the row echelon form, this is equal to 1. First of all, let us make this value equal to 0. Okay. So how to make this value equal to 0? I'm saying this is negative 3 and this is negative 15. So if I multiply this negative 3 with 5 and I subtract negative 3 with 5 will be giving us negative 15. So if I subtract this negative 15 from the third row, then negative 15, positive 15, that will be giving us a 0. So let us do that. Okay. So now I can write this as R3 minus, I can write R2 minus or R3 minus, same thing, R3 minus 5 times R2 is giving us R3. Okay. So the first row stays 2 minus 1 and 1. 0 minus 3, 5 and 6. And now coming to R3. So 0, R3, this one is 0. 0 minus 5 times 0, it is 0. Coming to the second place. R3 is negative 15 minus 5 times R2. 5 times negative 3 is negative 15, minus of negative 15, negative of negative 15 is positive 15 and this is negative 15. So this is 0. Now coming to this is 25 and then 5 times this is 5. 5 times 5 is 25 and 25 minus 25 is again a 0. So I have got all the 3 zeros on the left side of this vertical line. What about the right hand side? Right hand side, this is R3 is 77 and 5 times R2, 5 times 6 is 30. Okay. So 77 minus 30 is 47. Okay. So I am seeing that the left hand side is containing all zeros, but the right hand side is a non-zero number. What is this row? telling us? It is telling us you see, these are the coefficients of, this is the coefficient of x, this is the coefficient of y, and this is the coefficient of z, because that is how I had started this matrix. I had taken all the coefficients from one, the first row, the second row, and the third row. Okay, coefficients of x, y, and z. So this third row is nothing but 0x plus 0y plus 0z, which is equal to 47. Doesn't matter what is the value, what are the values of x, y, and z. When multiplied with 0 will be giving us a 0 product. So it is basically 0 is equal to 47, which is meaningless. Right? You cannot have 0 to be equal to 47, a non-zero number. So this shows that, let me read this once more. This shows that the system of equations is inconsistent, hence the three planes do not interact. Okay, I have done using this matrix method. You may do it in your the method that you have known from so many years. Um, that is the solving of the simultaneous linear equations. You may take, first of all, you may take these two. You may take, in fact, any two equations, eliminate one of the variables, and then you take another two equations and eliminate the same variable. You will be getting two equations involving two variables, same two variables. It may be xy or xz or yz, any two variables, and you will be having two equations, two variables, two unknowns, so you can solve. You will be getting some values, and over there also you will be seeing that you are coming with up with an absurd situation. You will be having 0 equal to some non-zero number. Okay, so that also will be proving that this is absurd, it cannot happen. That means these three planes do not interact. Okay. Subpart B. This containing two further subparts I and II. The I says verify that the point P with coordinates 1, -2, and 0 lies on both pi 1 and pi 2. And these are the three equations of the three planes. Fine. So we start with I. Since we have to prove that the point P lies on both the planes pi 1 and pi 2, let us put these coordinates, these values, let us substitute in these equations. First of all, I am taking pi 1. The left hand side of pi 1 equation is 2 times, in place of x, I am writing 1, this one, minus y, so y is -2, plus z is 0. So this is 2 plus 2, which is equal to 4, which is the right hand side. So therefore, P lies on pi1. Okay. Similarly for pi2, sorry, the left hand side is equal to x is 1, so 1, minus 2y, so minus 2 times minus 2, plus 3z, plus 3 times 0 is equal to 1 plus 4, which is equal to 5, which is the right hand side. Okay. Therefore, so the coordinates of P satisfies the pi1 equation and satisfies the pi2 equation. Therefore, we can conclude that the point P is lying on both the planes. Since point P is lying on both the planes, therefore, point P is lying. We do not know whether whether the planes are meeting at. There are three planes, in fact. Whether the three planes are meeting at a point or in a line, we have no idea. But uh, when there are two planes and there is a single point which is common to both the planes, that proves that these two planes are intersecting in a single line. Two planes can either be parallel to each other or it can be coinciding, though the two planes can be coinciding, or else they can be intersecting. In this case, because the point P is lying on both the two planes and the two planes, they don't have the same equation, so they are not the same identical planes. Therefore, we can conclude that these two planes are intersecting and the there is the common line of intersection which will be lying on both the planes. Okay. So this is lies on pi2. Fine. So we have completed answering I. Coming to I. Find a vector equation of L, the line of intersection of pi1 and pi2. We have already understood that these two planes are intersecting in a line and there is the common line of intersection which they have named as L, and we are required to give the vector equation of that line L. And in order to get the vector equation of a line, what do we need? We need a point. We need the coordinates of a point which is on the line, and as we know that obviously the point P is on the line because P is the point which is common to both the planes, so it will be lying on the common line which is on both the planes, which is the line of intersection. So this point P is on the line L. Maybe uh, I can draw two arbitrary planes. Maybe this is pi1 and maybe this is pi2 and this is the intersecting line, this is the L. Okay. And maybe the point P is somewhere on the line L. And I have drawn this as a small rectangle, but actually plane it is not, it is an unending plane. Okay. So this is just a rough sketch. And now what else do we need for the vector equation? We need the direction vector of the line. We have the point which is on the line L. We need the direction vector of the line L. How do we get the direction vector of the line L? Well, we know the direction vector of the line L So that what information are we having? We are having the information of the normal vector to the plane pi 1 and the normal vector to the plane pi 2. Okay. So what is the normal vector? So it may be I'm naming the normal vector for pi 1, maybe this is as named as n1. This is equal to 2, -1 and 1. Okay. And the normal vector for the plane pi 2, it is 1, -2 and 3, right? The coordinates. We know how to get the normal vector from the plane equations. So these are the two normal vectors. So maybe this is the normal vector for the plane pi 1, and maybe this is the normal vector for the plane pi 2. Okay. And now we know that n1 is perpendicular to the plane pi 1. So it is perpendicular to every line which is on the plane pi 1. So of course n1 is perpendicular to the plane line L as well. Okay. And we know n2 is perpendicular to the plane pi 2. So n2 is perpendicular to every line which is lying on plane pi 2. And since the line L is lying on pi 2, therefore the n2 is perpendicular to the line L. Okay. So n1 is also is perpendicular to the line L. N2 is also perpendicular to the line L. Okay. So suppose we are having this plane and this plane, and you are having a perpendicular. This is the perpendicular to this plane, and this is the perpendicular to this plane. Okay. If you take the cross product of these two perpendiculars, the cross product, it will be also be a vector. So it will be having the direction along with the magnitude. And what will be the direction? It will be perpendicular to both the vectors n1 and n2. So because the resultant of the vector, the cross product of these two vectors or the vector product of these two vectors will be a vector which will be perpendicular to both the n1 and n2. Therefore, that cross product vector should be parallel to pi 1 and should be parallel to pi 2. Okay. That means it is parallel to the line L. A line which is perpendicular to the perpendicular of a plane is parallel to the plane. Understand this. This is a plane. This is a perpendicular. So if I draw a perpendicular to this perpendicular, it will also be this way. Okay. So this one is parallel to this. So a vector which is perpendicular to the perpendicular of a plane is parallel to the plane. So if we take the vector product of the n1 and n2, the vector that we will be getting will be parallel to the planes pi 1 and pi 2. So it will be parallel to the line L. That can be taken as the direction vector because it is parallel to the line L. So that can be taken as the direction vector of the line L. Okay, fine. So first of all, let us get the vector product. N1 cross N2. So this is I, J, K. and n1 is 2 minus 1, 1, and n2 is 1 minus 2 and 3. Fine. So this is equal to I minus j plus this is k. Okay. So I is what? Negative 1 times 3, that is negative 3, minus of minus 2 times 1 is minus of minus 2, which is plus 2. And j, you are having a negative sign in front for j. It is 2 times 3 is 6, minus of 1 times 1. For k, it is 2 times 2, 2 times negative 2, it is negative 4, minus of 1 times negative 1 is negative 1. So negative of negative 1 is positive 1. So this is equal to minus 3 plus 2 is minus 1. So it is minus I. 6 minus 1 is 5. So minus 5j. And minus 4 plus 1 is minus 3k. So this is the vector which is parallel to the line L. So this can be taken as the direction vector. Okay. So therefore, vector equation, this is the direction vector. Vector of L. Okay. Therefore, vector equation of L is equal to or is R equal to, the point is 1 minus 2, 0. So the position vector of this point is 1 minus 2 and 0 plus lambda times minus 1, minus 5 and minus 3. Okay. So this is the answer for the subpart I. Now we come to subpart C. Find the distance between L and pi 3. We had found the vector equation of the line L. This was the vector equation, and over here you are seeing the direction vector was minus 1, minus 5 and minus 3. You can take out this common minus sign outside and write the direction vector as 1, 5 and 3. But I have kept all the minus signs inside because during the time of examination you may not be noticing this, and also there may be students who may not be just realizing that you can take the common minus sign outside. So if you keep those minus signs in within the direction vector, you are not wrong. This is perfectly correct. So you may keep those minus signs. Okay. So that was the vector equation of the line L, and this is the equation given for the plane pi 3, and this was the coordinates of the point P which is lying on the line L. Okay. And you are required to find the distance that is the shortest distance or the perpendicular distance. So maybe this is pi 3 and maybe this is the L, maybe this is the point P. You can take any point on the line L because I know the coordinates of this point P. I am taking the point P. And this is the perpendicular distance. Maybe this is a line on the plane pi 3. So this is perpendicular. Okay, this is a 90-degree. You can take any plane, any line on this plane pi 3. This will be perpendicular to that line. All the lines lying on the plane pi 3. And let me name this foot of the perpendicular as M. Okay, fine. So what do? We have to find the shortest distance. So for that, um, we may be requiring to find the vector equation of this line PM. Maybe let us see. If we try to find the vector equation of this line PM, let me just name this line L1. Okay. So this line is normal, this PM or MP, whatever you call it. It is named as L1. This L1 is perpendicular to the plane pi 3. And what is the perpendicular vector to this plane pi 3? We can get it from the vector equation of the plane pi 3. So the perpendicular vector, the normal vector to the plane pi 3 is this one, -9, 3 and -2. Okay. So we want to find the vector equation of the line L1. And in order to find the vector equation of the line L1, we need two things. One is the coordinates of a point lying on that line and the direction vector of the line. So L1 is perpendicular to the plane pi 3 and we are having this perpendicular vector, normal vector to this plane pi 3. So this can act as the direction vector. And what is the point? We know the point P is on L. So we are having both the things. We can find the vector equation. So vector equation of L1 is R equal to the position vector of the point P is 1, -2 and 0 plus I have taken lambda over here. You may take lambda over here as well, doesn't matter, but I'm taking a separate parameter. I'm taking mu. So mu and the direction vector is -9 and 3 and -2. Okay, fine. So every point lying on this line L1 will be having coordinates as like, let me write, every point on L1 has coordinates the x coordinate will be 1 minus 9 mu, y coordinate will be -2 plus 3 mu, and the z coordinate will be 0 minus 2 mu, which is -2 mu. Depending on what is the value of mu, you will be having different points lying on the line L1. Okay, but the general expression for the coordinates of every point on L1 will be 1 minus 9 mu, -2 plus 3 mu, and -2 mu. Okay. So these will be the coordinates of the point M as well, since M is lying on L1. Even these will be the coordinates of the point P. But the mu value will be different for these two. points P and M. So, if the coordinates of the point M are these, then since the point M is lying on the plane pi 3, it should be satisfying the plane equation. So I am taking the coordinates of this point M as these, and I am substituting these values in the plane equation. So minus 9, 1 minus 9 mu plus 3 minus 2 plus 3 mu and minus 2 and minus 2 mu. Okay. Minus 9x. So in place of x, I have written 1 minus 9 mu plus 3 y. So minus 2 plus 3 mu and minus 2z. So minus 2 times minus 2 mu equal to 32. So from this equation, we will be finding the value of mu for the point M. So we expand. So this is minus 9 plus 81 mu minus 6 plus 9 mu and okay plus 4 mu equal to 32. And 81 plus 9 is 90, 90 plus 4 is 94 mu. So it is 94 mu is equal to, this is minus 9 minus 6 is minus 15. If we add 15 to both the sides, we get 32 plus 10 is 42 plus 5 is 47. Therefore, mu is equal to 47 over 94. 47 times 2 is 94. So this is equal to half. Mu value is half for the point M. Okay. And now you can have to find the distance between these two, the plane I3 and the line L. So basically you have to get the length of this PM. Okay. So you can use the vector method, no harm. But I have seen many students getting confused with the vector method. So I will be using simple distance method. First of all, I know the coordinates of the point P. I will be getting the coordinates of the point M. And as soon as I get the coordinates of 2 points, I have the coordinates of 2 points, and I can use the distance method to find the length. Okay, so therefore, M will be having coordinates as 1 minus 9 over 2 minus 2 plus 3 over 2 and minus 2 over 2. So this is M. Minus 9 over 2 is minus 4 and a half. So 1 minus 4 and a half is minus 3 and a half. 3 and a half is 7 over 2. So it is minus 7 over 2. And this is minus 2. 3 over 2 is 1 and a half. Minus 2 plus 1 and a half is minus half. And this one is minus 1. Okay. And the coordinates of point P will be 1, minus 2 and 0 given. So, therefore, distance between L and pi 3 is equal to So 1 minus of minus 7 over 2. So it is plus 7 over 2 whole square plus minus 2 minus minus half is plus half whole square plus 0 minus 1 whole square, which is 1 is 2 over 2. So 2 over 2 plus 7 over 2 is 9 over 2 whole square. 9 square is 81. 2 square is 4. This one is minus 2 can be written as minus 4 over 2. So minus 4 plus 1 is minus 3. Minus 3 over 2. Minus 3 whole square is 9. 2 square is 4. And this is minus 1 whole square is 1, which can be written as 4 over 4. Okay. So this is 81 plus 9 is 90 plus 4 is 94 over 4. So this is equal to root 94 over 4, which is equal to root 94 over 2 units. Okay, so this is the answer. So with this, we come to the end of this question number 11. And I am Nilanjana Sanyal. I am an online IB Math ASL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring sessions to my students. And as you are seeing, currently I am solving the IB Math HL past paper questions, and I'm making videos of these and uploading these in my YouTube channel. So in case you are liking my explanations, please give these videos likes and please share these videos with your friends so that even they can get benefited by watching these videos. And in case you have any question, any doubt, any query, please feel free to write to me in the comment section. I'll be trying my level best to answer your questions. And please to subscribe to my YouTube channel. It will be motivating me to make more math videos for you in future. And thank you for staying with me till the end. We meet again very soon in our next session where we'll be solving question number 12. That is the last question of the same paper. So till then, bye.